Hello and welcome to episode 2 of the Pre-Calculus podcast. I am your host. Today our topics are going to be arithmetic sequences and series. So let's get started, shall we? But first, let's have a word from our sponsors. No, we're not sponsored. Why aren't we sponsored? No? Can we just make it up? No? They got mad last time. Alright, well, apparently we don't have a sponsor. So, this episode is brought to you by water. You need it. You drink it. You have too much and you might die. So let's begin. So arithmetic sequences are sequences that have a common difference. And a common difference is something that's usually either added or subtracted to increase from one to the other. So a way to find your common difference, which is usually labeled as d, you're going to take an, so the current number that you have, and you subtract it by the number that came before it. So if I take the numbers like 1, 2, 3, if I take the number 3 and subtract it by the number 2, which came before it, I end up with my difference of 1. Okay? And in an arithmetic sequence, that should always be the case. No matter what number you pick in that sequence, when you take the one before it, it should also have the same difference as if you took the first and the second number. That is what an arithmetic sequence is. So it has a common difference. So let's look at some of these differences that we have and see if we can find if there is a common difference of these arithmetic sequences. So looking at the first one, okay, if you want to play along, you can, pause this video and be able to answer them yourselves. I'll give you time right now. Alright, so with this first one, if we take the second number and subtract it by the first, 120 subtracted by 100, we end up with 20. If we take the third and subtract it by the second, we get 20 also, which means that we have a difference here of 20. So the difference in that first example would be 20. That would be our common difference. Now if we do the same with our second one, you see it's a little bit trickier, but you know what? You could probably still do it. When you do your subtraction, you end up with 2.37. And if you do it with the next one also, you end up with, again, 2.37. And now moving on to the last one, you go 15 and 12 and 9. You see in this case you're decreasing, not increasing. So that means that instead of adding the number, you're going to be subtracting. Or if you want to be kind of pretentious, you can say that you're adding a negative to both sides. But you're subtracting. Come on, let's be real. You're subtracting 3. Make it simple. Okay. So you're subtracting 3 on both. Okay, so those are all common differences that we have. All right. Now, what if we want to find, instead of just one number, we want to find the next number, we want to find the 10th number, or the 12th number, or the 715th number. Okay, so you see how if I go, oh, what's the 10th number, you can go, well, I'm just going to keep adding until I hit 10. But when I ask you to do it to the 1,000,000th number, you're not going to want to count to 1,000,000. Nobody wants to count to 1,000,000. That's a lot of numbers. So that's why we have a formula, because the formula makes it a lot easier. So a sub m, or a sub n, so whatever number you want to find, you end up just taking the first number. So this right here is the first. So the first number in your sequence. N is the nth term you want to find, and d is your common difference. So if we look at this first example, where if we want to find the 12th term of this sequence, 17, 19, 21, we would end up going 17, our first term, plus 12, that's our n, minus 1, times what our difference is. And our difference here is dos. That's Spanish for 2. Okay. And so now we would go through and calculate this. So it would be 17 plus 22, which ends up with our answer of 39. Okay. So now take a minute and answer the second one. Try to find the 1,234th number of this sequence. Okay. Hopefully you did it, and you ended up with your answer of about 1,235 all over 6, because our first term's a third, and the difference going forward is 1/6, or 0.16 repeating. Okay, so now what if we want to do a sum? Okay, and do you guys remember what a sum is? It's called a series. So we want to find the series of these numbers. So 1, 2, 3, all the way up to 100. So one way that we would be able to do it would be just to add them all up. And when we add them up, we end up with 5,050, which sounds like a nice round number, and it is. And the reason why it becomes a nice round number is because when we start adding, if we go 1, 100, and then we start going backwards, 99, 98, and 2, when we add these together, you see if we go from the extremes on both sides and we add them up, we end up getting hundreds. And how many hundreds do we get? We get 50 of them. And then we have a leftover 50 right in the middle. So that's why it's 550. Okay. So now what if we wanted to move it on to the first million numbers, which again, this would be a giant pain, and nobody wants it to be a giant pain. So, thank Gauss. So the story goes is that in 3rd grade he was given this exact same problem to find some of the first 100 problems, and it was one of those that it's like, the teacher, just wants to sit back and relax and let the kids just do some basic math, and he created this formula because of it. Now, is that true? Probably not. But, fun stories are fun stories. George Washington didn't chop down a cherry tree. Okay? That's, fun stories. So, he came up with this formula. So, this is the formula for an arithmetic series. Now, when we want to add these up, we're going to use this equation. S of n is equal to n over 2 of a1 plus an. So, n is is the number of terms. Okay, so that's how many terms you have in your series. And a1 is your first, and an is your last. So, if we do this example with 101, so once we take that 1 plus 100, okay, so that'd be 101, and we'd multiply it by how many digits were there from 1 to 100? Obviously, there's 100 over 2. So we take 101 times 50, which ends up getting us our answer of 5050. Okay. All right, so now you have examples like these, which you see your difference is, in the first case, 9. And your second one, your difference ends up being 100. So what you have to do with these is that you have to find what your n is to help you find what your sum is. So you'd have to find how many numbers in this sequence until we get up to 100. And that's where you can go back and use your a1 plus n minus 1 times d, okay, equals an. And what you can do is you can plug the 100 in for an, 1 in for a1, and then you're trying to solve for n. And then d in this first case would be 9. And you'd go through and you'd solve it for what they are. Okay, and you'd find what n is, and then you would go through and you'd find what the sum is. So right now I want you to take a minute, I want you to find what the n is, and then use that to help you find what the sum would be. Okay, so with this first one, we find out that the n is actually 12, and our sum would end up being 606. Okay, and now in the second one, our sum ends up being, or our n ends up being 11, and our sum ends up being 5665. Okay, so for those, you have to find your n, in which you have to use this formula at the bottom first, and then you can use that to help you find your s of n. Okay. Okay, so now let's say we want to find the sum of these. Now, if we want to find the sum of a summation, it's kind of simple. First off, we have to find what two things do we need to find for our formula. We need to know how many there are, we need to know what the first term is, and we need to know what the last term is. But we don't need to know what the difference is. So all we have to do is we have to plug in what our first term is, which is plugging in a 1. There's our first term, so that's our A1. Plug in the 40, that's our AN. And the numbers from 1 to 40, how many are that? There's 40 of them. So that means our N equals 40. And so we would use that to find the sum. So take a second to find the sum of this first one and the second one. Okay, so with the first one, hopefully you found out that your first term was 5, your last term was 83, and we'd plug it into our formula with n being 40, and we get 1760, so 1760. Okay. The second one, we do the exact same thing. Our first term, in this case, would be a negative 3 over 4, and our last term would be 4. And then our n, in this case, ends up being 20, because we have to include 0, so it'd be 0, 1, 2, 3, 4. And as you see, it gets you 1 extra. And we do our whole calculation, and we end up with 65.5. Okay, so that's finding the sum based on these summations using sigma. Okay, so let's say we are sitting in class. So Seth is bored in history class, because no one's ever bored in math class. I never was bored in math class because math was always the best class, most exciting, bombs going off and everything and exciting. Anyway, and he decides to stack pencils. The top layer of the pencils is 10, the second row is 11, 12, all the way down to the 15th. He runs out of pencils. So then Kathy turns to him and asks how many pencils were in his tower. First off, how many pencils did Seth use? If Seth continues the tower, how many pencils would be in the 115th layer? And how many total pencils would be in this tower? So I want you to take a minute. I want you to find out how many pencils did he use to make his 15 layers, how many would be in his 115th row, and how many total would be in it if he went all the way up to the 115th row. All right, so with his pencils, how many pencils he would have in his 15th row, you would start with 10, and you'd end with 25, and you would end up finding your answer of 255 pencils. Okay, if you continue it to the 115th row, we end up with 124 pencils just in that last row. And the last question, how many pencils would be grand total in that tower? That would be 7705 pencils. Okay, so those are our summations. So here's your homework from this section that I would like you to do. Thank you for being here. Like and subscribe and other such things that they tell me to say. Why do I have to say this? Everyone says, why does everyone say it? It's stupid. But fine. Like and subscribe. You want me to say mash? I'm not going to mash anything.